So today our mechanical engineering students going to discuss about the case study topic of synthetic line following robot. Okay, let us see.
And yes, we are going to see about the synthetic line following robot by the DT approach. By the design thinking approach, we have the framework of 5 stages: empathy, define, ideate, prototype, and test. We all know that what empathy, define, ideate, prototype, and test that denotes. And when we come to this synthetic line following robot, we are straightly approaching that we have a problem statement as the cleaning robot's efficiency is so low, so we are developing a synthetic line following robot, and we have defined and finalized the problem statement. And the idea we brainstormed and discussed that to develop this robot with the sensors and the line followers by making it adjusted, and we have made a prototype which is now working, and the test stage will be explained. Now Kishorji will be explaining the ideate process fully.
So, as mentioned, the major problem is the synthetic tracks are plastic or rubber composite material. Hence, it's not like a sand road, not like a sand track. So the athletes can't use other shoes. They usually use spikes, the long wheels and short wheels. When they are moving in a certain force and speed, the major injuries can cause, like ligament tear, and it makes them to break down their career more than 3 to 5 years. So they can't even to rejoin the competition or other things for more than 3 to 5 years. They need to recovery and rehab, and they need to restart the process, and they need to regain the PR, maximum strength to attain the. So for that we have been found that we have modified the line follower robot. The line follower robot with 3 wheels and their base module. It's attached with the major controller, microcontroller, and the 2-stepper motor, and it's attached with the hydraulic cleaning bushes and vacuums, because the small muds and sands will be caused a major problem in the synthetic track. Hence, to vacuum that and clean all over the track, majorly the track structure will be in a curved format, and they will be lined in a white line. They will be lined a white line in a separate track. So we will program the line follower robot. We will say the robot will sense the line. So it will clean the whole track. It will be divided into 6 tracks, 6 to 7 tracks, as the size of the road. So it will be easily without a manpower. It will autonomously clean all over the track without any manpower. So it reduces no need the manpower first of all. Then it reduces and it increases the accuracy of cleaning. So with human cleaning, and the machine robot cleaning, it will back up. So all over the precisely 80 to 90% of the dust and sand will be clean. So the athletes can easily able to run in all over the thing. So even though we can attach some moisturizer and other sensors to test the track with. In the rainy season, the tracks will be slippery. So they will use the metal needles to in the spikes.
So as Kishore said, the track which here the athletes are running, the tracks has multiple lanes. So he said that the point which is the spike shoes that the athletes are using. That's the main empathy that we have found out in this problem. So while running, that may cause some injuries to them. So as coming to the technical point of view, Kishore said that synthetic line follower robot will goes on the line track. So while we are cleaning with some vacuum designs, and we know that in our houses we are using some cleaning robots that will clean according to the house's boundaries, that we will automatically feed. But in the athletic tracks, we will make the robot to follow the lines. So the robot will follows the line, and then it cleans the track. So let's clean the track in many ways. We can use vacuum cleaners to clean the track, and we can somehow during rainy days there will be some waters will be there. Like he said, the moisture sensors we using, it will clean that that too. While going to that, let's clean that also. So next the in various applications where it's used will be the technology.
So these technologies can be variously applied to. There are so many sports events that are being conducted in the stadiums like Asian Games, Olympics, national sports. So this can be applied across various stadiums. That's the technology. So next he will explain.
Now we will see the application in various standards. We can also use till roadsides, while many of them are using like many roadside dust also have to clean. In road is the right side, in right side and left side as well. So like the muds and the dust will be there. We can use you can use the following right side white line of the road. We can adjust the robot to the modification so that the robot will follow the line and it will clean the highway roads also, as well as we can use in service road also.